Okay, this is the last of the videos which is going to see us solving trigonometric equations with the aid of a calculator plus a sketch. Okay, let's have a look at this particular question then. I've got a sketch of y equals tan x that is being asked for in part A of the question. So for part A then, let's do this sketch, and this time we're doing a tan graph, so y and x axes like so. Now when you're doing a tan graph, the first thing that you should set up for your sketch are the dotted line asymptotes. And these dotted line asymptotes occur at certain x value degree values. So what you need to do is go 0 and then 90, 180, 270 and 360 if we want to show the graph between 0 and 360. And the asymptotes are located, if you remember, at 90 degrees and at 270 degrees. So we place those asymptotes in place. Now you've got them in place, you now draw the sketch of the curve y equals tan x. And if you remember what it looks like, this middle section between the two dotted lines sees the tan graph going from down there, negative infinity, passing through 0 there, and straight up to plus infinity at that side of the picture. So there we go, there's the middle section. Now if you remember, that basic tan-shaped graph is repeated over and over again in both directions. So what we get from 270 to 360 is the start of the same curve again, which is the bottom half of the curve. If I carried on the angles to 360 and then another 90 and another 90, you get the second half and another asymptote. Okay, going this way, we've got this curve being repeated again down here, but you're only getting the top half of the picture. If you carried it on with the negative axis, you'd get the bottom half down here on the negative, up to negative 90, shooting off to another dotted line at minus 90. So there's the sketch of y equals tan x. You get that basic curve that is being repeated over and over again in both directions. So from 0 to 360, that's the sketch. Okay, so I've done the sketch. What I need to do now is solve this equation with the sketch together with a calculator. So, okay, I'll write it down over here. So the equation is tan of x is 1.2. So what I'm going to do first of all is look up on a calculator what the calculator suggests is the answer. So I'm going to go to my calculator, and to go from tan x to get x, I used shift tan button, or the inverse tan button, or the second function tan button. So here we go. It's going to be shift of tan 1.2, and that gives an answer of 50.2 degrees. So 50.2 degrees. Now, is 50.2 degrees within the range that we're asked to solve? Well, if we're asked to solve this, we're going to use the same range as part A, 0 to 360. Okay, they would probably specify here as well the range 0 to 360 again, but okay, I will take it as read, we're doing the same range 0 to 360. So yes, that lies between 0 and 360, so that's going to be one of the answers. But the calculator only gives you one answer. Remember, there may be more than one answer in the range we want. So how do we use the sketch to make sure we've got all answers? So you now go to your sketch and we say, right, okay, I'm going to solve things graphically. If I was going to solve things graphically, I need to do a picture of y equals tan x. Well, there it is, between 0 and 360. There is y equals tan x as a sketch. I also need to do now a graph of y equals 1.2. Y equals 1.2 is a horizontal straight line. So I'll get a colour and do this in a different colour. So you go to 1.2. Well, I don't have any numbers at all going on the y-axis for a tan graph, because there are no important values that you need to memorise. Remember, when you had a sine graph or a cos graph, we had +1 and -1 to memorise. You do not have those values on a tan graph, because the graph shoots off to infinity and down to minus infinity, so there are no specific values you have to learn. So when I say tan x is 1.2, the y equals 1.2 just simply requires you to go somewhere on the positive y-axis, anywhere you like, doesn't have to go any particular position because it's not an accurate picture, indicate 1.2 on the scale, and then draw a horizontal line going straight across and label it y equals 1.2. So I've got the two graphs drawn. I've got the tan graph in black and I've got the y equals 1.2 in red horizontally. The solution to the equation now will be where those two graphs intersect. Those two graphs intersect in that place there and that place there. The x values, which are the solutions to the equation, can be found by dropping down to the x-axis like so. Okay, and you read off the scale. Now, if it was an accurate tan graph, you could read off accurately from your x-axis values what those answers are. But this is a sketch, remember, so you can't do that. So now we look at the calculator answer to help us with the graph to get the answers. The calculator suggests the answer should be 50.2. Well, looking at this, I can see that this answer here actually lies between 0 and 90. That corresponds to the 50.2 the calculator says. So that's the first answer. That's 50.2. To get the second answer, we now make use of the symmetry of the situation for the curve. And just like the sine and the cos graphs, we do have symmetry taking place. You should be able to see that we have a little region here which looks very similar to a little triangle, and that is exactly the same shape that exists there. So we have a symmetry of values going on. This gap from 0 to 50.2, which is like the bottom of this little triangular shape here, that is a 50.2 gap. So that must mean that that gap from there to there is a 50.2 degree gap. Okay, a 50.2 degree gap. Well, what does that mean then? Well, this reading here we can easily work out because we know that is 180 there. We know the gap is 50.2. So if you add 50.2 to 180, you'll get that reading. And if you do that, here comes the second answer. 180 plus 50.2 is 230.2 degrees. And that is our second answer between 0 and 360. If you want to make a note about how you get that, it's from symmetry, and you get it by saying 180 plus a 50.2. Okay, so on the picture, that would be here 230.2, which makes sense if you look at the figures on the x-axis, 180, 270. And there you go, there is the solution to this equation. Tan x equals 1.2 using a sketch and using a calculator to help. And that's the end of this short video.